If you remember, we calculated the mean, variance, and standard deviation of Dr. Shanan's statistics class. These calculations are easily performed in Excel. So here in program 2.1a, it shows the inputs and formulas in Excel for calculating the mean, variance, and standard deviation. So itong x dito sa table is the random variable. Next column is the px or the probabilities. Then next is x times px or random variables times probabilities. Yung products dito, i-add natin lahat to get the expected value. So kung makita natin dito ang formula niya is equal sum open and close parenthesis C2 to C6. Next column is random variables minus squared of the expected value times px or the probabilities. So kung makita natin dito sa formula, naglagay tayo ng dollar sign around C. Why? Because we want C7, which is the number here, yung expected value dito, to be fixed. That won't change, that won't indexes. Then yung answer dito, yung sum ng D2 to D6, that will be our variance. Then the square root of the variance will be our standard deviation. So let's proceed to program 2.1b. After natin malagay yung mga formulas, this will be the Excel output for the Dr. Shannon example. Ang expected value natin is 2.9. Then our variance is 1.290 and the square root of that variance will be our standard deviation and it is 1.136. Now, we will proceed to the probability distribution of a continuous random variable. There are many examples of continuous random variables: the time it takes to finish a project, the number of ounces in a barrel of butter, the high temperature during a given day, the exact length of a given type of lumber, etc. Since random variables can take on an infinite number of values, the fundamental probability rules for continuous random variables must be modified. First, the sum of the probability values must equal 1, and second is the probability of each value of the random variable must be 0. If the probability values for the random variable values were greater than 0, the sum would be infinitely large. The probability distribution is defined by a continuous mathematical function called the probability density function or simply the probability function. It is usually represented by fx. When working with continuous probability distributions, the probability function can be graphed, and the area underneath the curve represents probability. So, how to calculate the probability density function? To calculate the probability density function, we just need to calculate the area under the curve associated with the range of interest. We now look at the sketch of a sample density function in figure 2.6. This curve represents a probability density function for the weight of a particular machine part. The weight could vary from 5.06 to 5.30 grams, with weights around 5.18 grams being the most likely. The shaded area represents the probability the weight is between 5.22 and 5.26 grams. We have to understand that for any continuous distribution, the probability does not change if a single point is added to the range of values that is being considered. In figure 2.6, this means the following probabilities are all exactly the same. Probability of 5.22 less than x less than 5.26 is equal lang siya kung i-include natin yung 5.26 like this, less than or equal to 5.26. Equal lang din siya kung include natin yung 5.22 or probability of 5.22 less than or equal to x less than 5.26. Equal lang siya because our probability is 0. And equal lang din siya sa p of 5.22 less than or equal to x less than or equal to 5.26. Adding any point or not adding that point has no impact on the probability. That's all. Thank you for listening.